In this video, we're looking at problem 9 from worksheet 9 of outcome 2 for engineering math 3. This problem is an example of integration by parts problem. So what we'll be doing here is trying to take this integral and use our rule for integration by parts to turn it into an expression with a simpler integral in it that we can either integrate straight away or turn that in turn into an even simpler integral that we know how to manage. In this type of question, we're going to assign one of our two expressions which are multiplied together in the integral as u, and the other is dv by dx. U will be differentiated, so the derivative of u will be something we're dealing with, and dv by dx will be integrated. So we need to pick our functions carefully to make this actually make things simpler. Now, in a problem like this, we're always going to be picking x squared as a value for u. And the reason for that is, and we'll see this when we get to the expression for integration by parts, when x squared is differentiated, its derivative is 2x, and that's a simpler term to deal with in terms of our integration. We're going to need 2 rounds of integration by parts here. You'll see why when we get to it. But it takes us to a simpler integral, and from that simpler integral we take another step to get to the final answer. So let's start off by assigning u and dv by dx as I've indicated. We're going to say that u is x squared and dv by dx is e to the 3x. So to complete the information we need, we'll find du by dx, which is 2x, and we'll find v, which is the integral of e to the 3x with respect to x, and that is e to the 3x divided by 3, because that's our rule when we integrate e to the power of something times x. We raise e to 3x and we divide by the coefficient, the number in front of the x. So we have an expression here for v. So now we can use our rule for integration by parts. Just as a reminder, what that tells us is that if we have the integral of u times dv by dx, which is sometimes just written as integral of u dv, this is equal to u times v minus the integral of v times du by dx, sometimes just written as the integral of v du. So let's put in all of the information we have. Well, our left-hand side is exactly what we're given in the question. We'll write this out so we have it in full. X squared e to the 3x dx. And our right-hand side, we'll take this term by term and just carefully put things in so we know what we're doing. So u, that's x squared, that's multiplied by v, which we found was e to the 3x divided by 3, minus the integral of v again, so we've got e to 3x divided by 3, multiplied by the derivative of u, and that was 2x. Now this is an integral, so this is dx here as well. Now we can probably see at this point we're not going to be quite done with this. We still have an integral we can't deal with, but let's tidy things up a little bit first of all. So we're going to have 1/3 x squared e to 3x minus, now we can take all of our numbers out here, they don't need to be inside our bracket, so we can have 2/3 times the integral of, I'd like to get the x's first, so we'll have x e to the 3x dx. So we have definitely a simpler integral now. This is still not something we can deal with directly. We need to use integration by parts again. So we just take this integral aside just now. The integral of x e to the 3x dx. We'll select a u, a dv by dx again here, and we'll do the same approach as last time. We'll pick our x term as our u value, and our dv by dx we'll select is e to the 3x. So that means du by dx is going to be equal to 1, that's the derivative of x. In v, well, we could work it out again using our standard table of integrals, but we've just done this integral previously, so we know it's going to be e to the 3x over 3. So we can now write out this integral here using our integration by parts. Now, if we remember, it was u times v, first of all, so we're going to have x times e to the 3x over 3 minus the integral of v, so that's e to the 3x over 3 multiplied by du by dx. du by dx here is 1 in this case, and of course it's dx. And this is something that we can integrate directly. We're going to tidy this up first of all, but we'll integrate that. That's going to equal to 1/3 x e to the 3x minus 1/3 the integral of e to the 3x dx. And we've encountered the integral of e to the 3x dx multiple times in this question. It's going to be 1/3 x e to the 3x minus 1/3 times 1/3 e to the 3x. That's e to the 3x over 3 that we've encountered twice already. And that's the thing about the e, the power function. It's going to come back to itself again and again. So finally, we can write it out as 1/3 x e to the 3x minus 1/9 3x. And let's just be careful putting this back in. So what we've worked out here is equivalent to this integral here. So this is what we're substituting into our main function. So we still have this 1/3 x squared e to 3x. We still have this coefficient of 2/3 here, and that's been multiplied by what we've just worked out for this integral. So 1/3 x e to the 3x minus 1/9 e to the 3x. And we've finished all of our integration this line, so this is where we must put in our constant term. We must include a plus c from this point onwards, because we don't have definite limits, so this is where you introduce a plus c. So this is really the end of the integration, but we want to leave our answer in some kind of meaningful and useful form, in case we had a question where we were putting in numbers into this. So let's take it up a bit further. This term remains the same. We're going to have minus 2/9 x to the x times e to the 3x minus 2/27 e to the 3x. Of course, that's all plus c. Now we could look, and we will in fact look further into how we can simplify this and tidy it up a bit more. You should be able to see that e to the 3x is a common factor of all of the terms with the exception of the constant term. So taking that out as a common factor should be something we do automatically. Something that might be less obvious unless we do it in two stages, that we can also take out 1/27 as a common factor as well. And let's see that leaves us with. Well, if we take 1 e to the 3x and 1/27 out as a common factor from 1/3 x squared e to the 3x, what we're left with is 9x squared, because 9/27 is 1/3. That's where that 9 comes from. 1/3, take a common factor of 1/27 out, and it becomes 9. And play about that in your calculator if you're not convinced by that. Then we're left with minus, it's going to be 6x. Again, taking a common factor of 1/27 out of 2/9 leaves us with 6, because 6/27 is the same as 2/9. And with e to the 3x gone, we're just left with x. And lastly, and perhaps a bit more obvious here, minus 2. 2/27, take it 1/27, we're left with 2, e to 3x taken as a common factor. And we write plus c, of course, at the end. And this is the answer to question 9. Now, the important step is when we complete the integration, and that's where we first include the plus c term, I think it would be expected that anyone would be able to take a common factor of e to the 3x, and taking 1 over 27, well, that's gives us a nice neat quadratic in our brackets here, but not the end of the world if you don't spot that common factor as well.